let's look at surds now for a second. Now remember, surds are when you have any sort of nth root that would otherwise be irrational when you try to solve it. So you'd leave it in what they call surd form with the surd above it. So let's say like the nth surd of A. Now let's look at some of the laws that we use for surds. Okay, so now if I had square root of 2 times the square root of 2, that gives me the square root of 2 times 2, which is the square root of 4, and that's 2. Okay, that's the kind of thing we're looking at now. So in general, how would we write this? That's going to be root A times root A. Sorry, let me quickly just erase this. Giving us root A squared. Right? Another version of this would be if I had root A times root B, giving us root A times B. Like so. Makes sense. Okay. And then we can do the same thing with now division. Right? So if I had root A divided by root B, that would give me the root of A over B. Yes? And then another law we can look at, which people tend to forget for some weird reason, is if I had the nth root of A to the power of n, that cancels that out. And we end up simply with A. Now for this next one, I'm going to link us now from exponents right into surds and how we can use the two together. Right? So then, looking at this fifth one, if I said A to the power of, let's say 3, or let's rather change this 3 to a letter, A to the power of B, and all that taken to the root of C. So now how we write this out is that it becomes A, and then we can take this and write that in exponential form. So then we would have A to the power of whatever power you had here, which is B, and then that exponent is divided by the power of the root, which is C. So that's A to the power of B to the sort of C root would be A to the power of B divided by C. Okay, let's look at some surd examples. So for the first example, we have square root of 75 plus the square root of 48 divided by the square root of 12. Now usually with these surd questions, what we're trying to find is there's going to be one like common surd when we try to simplify these ones that can factor out and then cancel out, and then we'll be left with perfect squares that we can just sort of evaluate afterwards. So let's look at this. 75. Now let's try to think of the factors of 75 that make up perfect squares. So I think 25 by 3 would be 1. Let's look at for 48. That's going to be 16 times 3. So you can see a pattern forming there. Perfect square and then the number 3. Perfect square, the number 3. And at the bottom, let's try that one. 4 by 3, that's again perfect square times the number 3. And then we've basically found where we're going. So we can then, what we can do is we can then simply take out the perfect squares out of the square root by square rooting them, and then we're left with the random surds. So we can then have 5 times square root 3 plus, that becomes 4 times square root 3 divided by 2 times square root 3. My top is 5 root 3 plus 4 root 3, that's 9 times square root 3, that's 9 root 3 divided by 2 root 3. The surds can cancel out, and our final answer becomes 9 divided by 2. Simple enough, nothing too hectic. Let's try another one. The next one now is a surd equation. So example 2 would go like this. 2x minus 3 root x minus 2 equals 0. Now with surd equations, there's two ways of going about them. So we can either keep the surd on one side, take this number and, the number and the variable to the other side, square both sides and then work our way down. But I'm going to show you a different method now, which also works similar to the K method if you ever use the K method. Note that we've got the surd of x. X is simply the surd of x squared. So this is a quadratic of the surd of x. To make it look simple, let me just say this. Let root x be equal to k as a random constant. Then we see that this thing becomes root x is k, so therefore x is going to be k squared, right? Sorry, therefore we have 2k squared minus 3 times k minus 2 equals 0. And that's very easy. It's a normal quadratic like you've ever sort of solved that. And in that case, let's find our two brackets. That's negative, so it's going to be two different signs. So we're going to have 2k here and k here. We're looking for factors of negative 2 that are going to give us minus 3 in the middle. So we're going to possibly go for then 2 times a minus 2 giving us a negative 4, and a 1 times 1 which is going to give us a positive 1 to give us negative 3. So we put a negative 2 there, a positive 1 there, so it's going to be minus 4k plus k giving us negative 3k. Therefore we can put our answers k is equal to 2 or k is equal to negative a half. Then that way what we can see, sub back our now root x, say the square root of x is equal to 2, or the square root of x, the square root of x is equal to negative a half. Yes? And then the whole thing is trying to solve for x. So can the square root of something give us a negative answer? Well, yes it can. Square root of 4 can be negative 2. So then what we do is square this side, square that side, and square this side and square that side. So root x squared is simply x, 2 squared is 4, or root x squared is x, and half squared is a positive quarter. Simple enough. It's perfect. Let's try another one. Let me quickly just erase the board for us. Okay, the last one is one of these really tricky ones that they like giving in exams, and they make you panic because it seems like you're dealing with very massive numbers, and they always request that you don't do this with a calculator. So let's look at what it says. So for my final example, we're going to have the square root of 10 to the power of 2009, massive number, divided by the square root of 10 to the power of 2011 minus the square root of 10 to the power of 2007. Let me just write this one a bit bigger. There we go. Okay. And then it starts to look a bit, okay, well, we don't know what's going on here. But it's quite easy. Normally what you do is take your smallest one, right, for this case, and make that, let's say, x, for example. So let's let 10 to the power of 2007 be x. Just so that our sum just looks better. So now let's replace all the other ones. So now we've got, this is going to be 10 to the 2007 times 10 to the power of 2 at the top there, right, to give us, so if we break it down before we apply the x, it's going to be 10 to the 2007 times 10 to the power of 2, that gives us 10 to the 2009, and lower down, that's going to then be 10 to the 2007 plus 10 to the 4. That's 10 to the 2007 times 10 to the 4 minus, that's just going to be 10 to the 2007. So now we can look at it this way and then apply our x's. That'll simply be x times 10 squared, which is 100, right? That's going to be the root of x times 10 squared divided by, here we're going to get the root of x times 10 to the 4 minus the root of x. Then you can see we've got a common factor of square root x everywhere. We can take that out and then cancel that out. So we're going to have a square root x on the top and a square root x on the bottom. Okay, what's left there is the square root of 10 squared. Square root of 10 squared is simply just 10. Right? On the bottom, we're going to take out the square root of x. We left with the square root of 10 to the 4. That's simply 10 squared, which is 100. Minus 1. That cancels that. We're left with 10 divided by 100 minus 1, which is 99. Simple enough. Okay, try some of the activities we've given you guys and then see how you do. Awesome.